Let us look at a particular instance of two-dimensional collision. So here are two spherical objects kept, and the first object was moving along this straight line. So at a certain point it will encounter, so as it is moving it will come ahead and it will encounter the second object. So it will go ahead and collide with the second object. So what is important over here is the fact that the equation of coefficient of restitution E has to be applied at the point of contact along the line of impact, along the line of impact. This is how the coefficient of restitution should be applied. So basically the line of impact over here is going to be the line joining the two centers, and the point of contact is going to be this point. Momentum is conserved in vectorial format. So basically we can choose any two axes as far as momentum conservation is concerned. So initially this mass, let us say this mass is m1 and this mass is m2. So initially the mass m1 was moving with a velocity u1, and let us assume here that the line of impact makes an angle theta with the initial direction of motion of mass 1. So we now can conveniently choose our axis in this manner. This is one axis and this is another axis. So we can choose our x and y axis to be so. So one of our axis is along the line of impact and another axis is perpendicular to the line of impact. So we'll write down the momentum conservation equation. So initially the second mass was stationary, u2 is equal to 0 and u1 is as shown, u1 vector is as shown. So we can write down our momentum conservation equations along the x-axis as well as along the y-axis. So let us say we first choose the x-axis. Then in that case the initial momentum of mass 1 along the x-axis was m1 u1 cos theta. The initial momentum of mass 2 along the x-axis was 0. So m1 u1 cos theta plus 0, this is going to be resulting into m1 v1 in x direction plus m2 v2 in x direction. So the angle theta is known over here. So in this equation we have two unknowns, v1x and v2x. Similarly, the momentum is also going to be conserved along the perpendicular direction, the collision. So basically in the perpendicular direction only the mass m1 will go because the mass m2 has been impacted along the line of impact. So the mass m2 will necessarily go in along the x-axis as shown. So here the mass m1 is the only one that is going to have a velocity component along the chosen y-axis. So for that we can write down m1 u1 sin theta is equal to m1 v1y. So here only one unknown is there, v1y. We can easily see that v1y is equal to u1 sin theta. That's easily understood. In the first equation there are two unknowns, so we need one more equation. So that is where the coefficient of restitution equation comes in handy. Coefficient of restitution is applied at the point of contact along the line of impact. So along the line of impact, what does that mean? So the coefficient of restitution equation should be thus applied now. We should write down E has to be known, E has to be given, E is equal to minus of V2. So instead of V2, we have to write V2x because remember it is along the line of impact. So V2x is the velocity of mass 2 along the line of impact. So it is V2x minus V1x upon U2 minus U1. Basically this is the equation of coefficient of restitution applied at the point of contact along the line of impact. So by solving these three equations, this is one equation, this is the second one, and this is the third one, we get all the unknowns. Please understand that here mass 2 had zero initial velocity. If mass 2 did not have zero initial velocity, then in that case we potentially could have had four possible unknowns. Namely, in general in 2D collisions, the four unknowns present are v1x, v1y and v2x, v2y. Whereas the momentum conservation equation will give us essentially two equations. One is momentum conservation along x direction, one is momentum conservation along y direction. And the coefficient of restitution equation will give us another equation. So always in general, in the most general case, we are going to face a situation wherein the number of unknowns is 4 and the number of equations is only 3. So in such a scenario, one of the four unknowns has to be given in the problem statement. Only then we can solve this particular set of equations completely. Now let us understand a few more cases of 2D collision. Let us say we are looking at the top view. From the top view we are looking at a circular body that is coming and impacting on a surface and getting rebounded. So here the coefficient of restitution equation should be applied along this line, which happens to be the line of impact at the point of contact. So E equation always has to be applied at the point of contact along the line of impact. So this happens to be the line along which the impulse will act. So the equation has to be applied over here. Let us say there is another typical scenario wherein there is an inclined plane given. So this is an inclined plane, and let us say an object, let us say a spherical object is coming and impacting this inclined plane. So as it is impacting this inclined plane, the line of impact happens to be the line that is normal to both the surfaces. So it is normal to the circle, that means it has to pass through the center of the circle, and it is normal to the plane, that means it has to be perpendicular to the plane. So the line of impact is shown over here. So the coefficient of restitution equation has to be applied at this point of contact along the line of impact. So let us say there is a square like this. Let us say there is a square, and let us say a hexagon shaped object comes and hits the square. So let us say this object comes and hits the square over here. So in such a case, the coefficient of restitution equation has to be applied at the point of contact along the line of impact. So here, how would you decide the line of impact? The line of impact is going to be perpendicular to the surfaces of contact. So this is going to be the line of impact. This line is going to be the line of impact basically. Why? Because the hexagon is hitting along the corner. So the line of impact will be decided as per the normal to the square. Line of impact is generally perpendicular to the surfaces that come in contact, whereas here the point of the hexagon is coming in contact, so there is nothing like a perpendicular to a point. So that's why the line of impact is going to be decided to be the one that is perpendicular to the right hand side of the square. So this is the line of impact in such a case. So it is important to understand that coefficient of restitution equation in 2D collisions has to be applied at the point of contact along the line of impact.